Hello Year 7s. In a previous lesson we'll have looked at the start of powers, but we focused purely on to the power of 2 or squared. In this section 1.09 we're going to extend that by looking at powers of other values. So overall this doesn't really introduce any major new ideas. It just basically takes and extends on the idea that we have a base number and we have a power or indice or exponent that we are going to use to multiply that out. So just like before, when we had, for example, 10 to the power of 2 or 10 squared, that would mean 10 times 10, the base number 10 multiplied that many times. We just extend this idea to be other numbers, other powers. So in this example here, we've got 10 cubed, or 10 to the power of 3, which just simply means the base number 10 multiplied by itself 3 times the number that is in the power or the exponent or the indice space. So again, it's just an extension of that. So in this section, we're going to obviously see numbers that have more than just a square or to the power of 2. You can read through this all the way through, and of course you can watch the video if you like, but really that is the most important part of this section, that we are continuing to have a base value, the actual number, and we have a power, which is the number that's small and up to the top, and that simply means base number multiplied by itself that many times. So let's have a look at the examples that they have provided for us. So in the first example, it says state the base for this expression. So here we have 8 to the power of 5. So the 8 is the base value and the 5 is the exponent or the power. So it's asking what the base value is, so that's simply putting in the number 8 in this case. And of course this is a question where there is no working out to be done, so I don't need to see anything in your book. So let's submit that. And of course we are correct. If we then have a look at the second example, it says identify the power. So again, the big number here is the base and the smaller number up the top is the power or exponent or indice, depending what word you want to use. So out of the two, the 5 or the 4, in this case the 4 is the power. And again, there is no working out that you'd need to show for this question. For this last one, we have something that we will have some working out. Here we have 5 to the power of 4 over 5 to the power of 2. The over line or the fraction line basically means divided by. So let's start by writing this out as a sort of long equation if you like. So 5 to the power of 4 means 5 times 5 times 5 and one more times 5. So it's 5 to the power of 4, so 5 is multiplied by itself 4 times, and then that answer is going to be divided by, in this case, 5 times 5. So again, 5 to the power of 2 is 5 times 5, 2 times. Now, it's very, very important though that we actually add some brackets in here, because we must work out the top value first and then divide that by the bottom value. Okay, so if you want to write it out like this, that's perfectly fine, but you have to include the brackets then. Alternatively, you could still leave it in a fraction style, which would be 5 times 5. I'll just try and draw a bit smaller here. 5 times 5 times 5 times 5. So that would be our numerator, the number at the top, over still 5 times 5. By keeping it in this format, we essentially are putting brackets around this because we have to solve this number at the top and this number at the bottom separately to see what our fraction is, and then we would simplify or work out the fraction from there. But if we want to write it this way, we really need to include some brackets here to make sure we keep this value as one value and this value as another. Okay. There is also another way we could work this out a little bit differently, but for now, these are the two methods that I would recommend you use. So let's stick with this one first. So that's going to be equal to, now we'll solve this left-hand bracket first, and again, within the bracket, we will solve one operation at a time. So the first operation we have is 5 times 5. So what we have is open bracket, the 5 times 5, of course, is 25. And then that is still multiplied by 5 and multiplied by 5 again. Close our brackets, divide it by open bracket, 5 times 5. Okay, solving the next part of this bracket, so we've got 25 times 5 would be 125, so open bracket, 125 multiplied by another 5 still, that's our fourth 5 there, close that bracket, divided by, now I'm kind of keeping deliberately underneath just to help me remember what I've done. So 5 times 5 here. Okay, we can now finish off the last part of this bracket over here. So 125 times 5, well, that would be 500, 625. So, oh, we don't need a bracket anymore, sorry, because we've now solved that. So I'll just grab my eraser here. So 625, still divided by bracket 5 times 5. Okay, now we're going to solve this bracket because of course we still have some brackets. So we have equals to 625, sorry about my writing here using the mouse still, divided by 5 times 5 of course is 25. Okay, and we're now down to something that we can solve, and 625 divided by 25 is 25. So that would be our final answer over here. Now, if we were to look at this other one over here, we would again work out what this top is, and we would end up with that being equal to 625 at the top. And then we would still end up with the bottom being 25. And of course, we could put that in our calculator or do that, and would obviously end up in the same position with a final answer of 25. Okay, so both ways will get you there. I shortcutted this because I didn't actually work out each of the steps. I stole the number from over here that I'd already done all that math. But it's really whether you're more comfortable in this format over here or more comfortable in the fractional format. I would probably guess most of you would probably be a little bit more comfortable in this format over here. All right, now just out of curiosity, I'm going to do this in my calculator straight away just to show you how it could be solved directly with your calculator, not doing the working out. Remembering before I do that though, that it's very important that you do your working out. This is just to help you to check whether you got the right answer. So I now have my Casio simulator over here, the calculator you're using in class. So if I wanted to now double check I've got the right answer, again, do your working out first, but double check before I put the answer into Mathspace, I could use my calculator. And the way I will do that is I've got 5 to the power, so I'm going to use this X with a little square so I can choose what value goes up the top. Last time we just used the square option that's built in, but now I need this one. So 5 to the power of 4, okay? I can either do the divide by, but I'm even going to keep it in fractional format. So I'm going to put my fraction button. Oh, no, go back one step, sorry. So I need to try that again. So 5 to the power of 4, that's done. And then I need to do fractional there. So you can see I've got the 5 to the power of 4 there, and then I need to do 5. And I can just use it to the power of 2 button that I've got built in, ready to go. So you can see my equation on the screen is the same equation that I've got over here. So if I press my equals button, you can see my answer is correct, the 25 that I worked out by doing all the steps of working out. So you can go back and rewatch how I did that. The thing you might have missed, actually, in fact, I'll do it again. So the thing you might have missed is I did 5 to the power of 4, but I actually had to press the right arrow key to get off. So see how the little flashing cursor is still up in the powers area? I need to go right one, so it was back down onto this line, so that when I pressed my fraction button, I was down underneath the fraction. As I said, the other way you could have done it is 5 to the power of 4. Again, you still have to press your arrow button to get down back to the main line, and then you could say divide by, and again 5 to the power of 2. This is the same equation, just not in fraction form, and again if I press equals, I still get the same answer. So that's how you could check your working out before you put the result into Mathspace. But again, let's put that actual answer in and make sure that we were in fact correct according to Mathspace anyway. Submit, and there you go, we do have the correct answer. So going back to the notes again, this one really is quick and easy. It's about Continuing on with our investigation of powers, and instead of limiting it to just squared or to the power of 2, we can now have exponents or powers of any number essentially. But the process is the same. It is the base value multiplied by itself the number of times that the exponent or power or indices say. Off you go and do your task, remembering to show all the working out where it's appropriate. And as always, if you need any help, please make sure you're asking.